All right, let's start with lesson 5, metallic bonding. Metallic bonding is the second type of bonding that occurs between atoms, and specifically, metallic bonds only occur between metal atoms. To begin our understanding of metallic bonds, we have to discuss delocalized electrons, or what this term means. Now, this is an important concept to remember, that metal atoms have very low or relatively low ionization energies. So the valence electrons are easily removed or ionized from the valence shells of metals. Now, because of this, nucleuses of atoms, metal elements, loosely hold on to their valence electrons. So as a result, if there are no nonmetals around to form ionic bonds, then the valence electrons are going to just tend to wander off and become what we call delocalized. So essentially, delocalized electrons are wandering electrons. They don't really have anywhere to go. There's no nonmetal to take them to form a covalent or an ionic bond, so they just kind of wander around, and that's basically what a delocalized electron is. Now, kind of give you an example. Let's take, for instance, sodium. Sodium being a metal, it has a Lewis symbol of 1 electron in its valence shell. And since sodium has a relatively low ionization energy, that this first valence electron can be ionized, and if there's no nonmetal to pick it up to form that ionic bond, then that electron is just going to be free to kind of wander around. And sodium, as a result, is going to form a positive ion, positive 1 ion to be exact. And then we have that delocalized electron out there. And that delocalized electron is free to move, to wander in pretty much any direction that it wants to go. And so that wandering electron then is referred to as a delocalized electron. All right, so now let's get into what a metallic bond is. So essentially, a metallic bond is an electrostatic attraction. There's our word, electrostatic, again. It's an electrostatic attraction between a lattice. Now, what we mean by a lattice is we mean a crystal structure. All right? So metals form crystal structure lattices similar to ionic compounds in their crystal lattices. All right? But in this case, instead of having a metal and a nonmetal to form a crystal lattice, as we see in ionic bonds, this is only seen with metal atoms only in the crystal lattice. So again, a metallic bond is an electrostatic attraction between a crystal lattice of positive ions. No negative ions, because we don't have any nonmetals. So only positive ions and their delocalized electrons in the metal. All right, so what does this look like? Here's an example. We have a piece of metal here, as you can see in this picture, and we blow up this metal to a very, very, very teeny tiny scale. You will see that the metal is made up of a crystal structure, a crystal lattice, and the crystal structure is positively charged ions that we see here. So, for instance, we have all these positive ions, and these make up the crystal structure. And however these positive ions are arranged will determine what the crystal looks like. Now, in between this crystal structure is the movement of these wandering delocalized electrons, which we can see right here in purple. These are the delocalized electrons. They have been ionized from each one of these metals, resulting in the ions, in the metal ions that we see that make up the crystal. But these wandering electrons have absolutely nowhere to go. And so they are just going to wander throughout this crystal pattern. Now, that wandering of these particular electrons, what's interesting is that because the electrons are still negatively charged, they are attracted to the positive charged ion. And so the wandering electron, so as it's wandering around in that crystal structure, the electron, those delocalized electrons, are going to attract momentarily to a positive ion. And then it's going to break off the attraction and begin to wander again. And then it's going to form another attraction to another ion and then break off that attraction and wander some more. And so we get this attraction between these delocalized electrons and the positive ions, and then the attraction is lost, and then it moves some more and attracted to another ion and so forth. So we just continue get this electrostatic attraction between these delocalized electrons and the positive ions that make up this crystal structure. And those attractions form those metallic bonds that we are referring to here. All right, so that's generally, well, that's really what a metallic bond is. And so try to think about this a little bit. If you need to relook at this lecture video to really think about this model and how this metallic bonds work with these delocalized electrons attracting to the positive ions in that crystal structure, then do so. But this is really it, and this is all I really want to talk about with metals right now and metallic bonding at this point. Now later on in Unit 4, we will get a little bit more into metallic bonding and the properties that result because of this type of metallic bonding. For instance, because of metallic bonding and how it occurs, these low electrons being able to wander and move through this crystal structure, it allows for metals to conduct electricity really well, as opposed to other elements that cannot form bonds in this nature. Having delocalized electrons, they're not able to conduct electricity very well. All right, so study this. That's it for now. Prepare for a quiz over metallic bonding.